All right, welcome to the 3-3 video. Our goal here on the 3-3 video is to use function composition. Now, function composition. All right, so function composition simply states you plug one function into another function. I think of this like the Russian dolls. You know those Russian dolls where you could put a little doll into a bigger doll and into another one and into another one? It's sort of like that, where I get to take one function and put it inside of a whole other function. All right, so the notation that we use, the notation for function composition, right? What's the symbol, Stevens? All right, so the way we say this is f composed with g. Notice that this is a open circle. This is not multiplication. This is f composed with g, and most often we'll see it written as f composed with g at x. So I'm going to write this as f composed with g. Now, I like to rewrite these, and I don't like this f composed. I don't like this as much as I like the written another way. So I'm gonna write the letters. So f, g, and x. I'm gonna write those in the same order: f, g, and x. And now I'm gonna rearrange my parentheses. Right now, look, it just looks like g of x. That's right. And now, if I put my finger here, it looks like f of x. Well, what I'm saying here is, whatever's underneath my finger, we're going to plug into f. Well, we're going to plug g of x into f. All right, so remember, the letters stay in the same order, right? So when it's written like this, you could rewrite it where the letters are in the same order, but now you can clearly see that g is going inside of f. And the way I like to teach this is a little bit different. So, excuse me, bear with me as we go through this exercise here, okay? Let's say that f of x equals 4x minus 3. And then we get g of x, and that equals, let's just go with negative 2x plus 1. Okay. So now we have two functions, right? F of x and g of x. And if I were to say something like, what is f of 0? Well, f of 0, I'm going to take x and I'm going to replace it with 0. And we can simplify that, right? 4 times 0 is 0. 0 minus 3 is negative 3. No big deal. And if I wanted to, I could say f of negative 2. And we'd put 4 times negative 2 minus 3, right? That's negative 8 minus 3 is negative 11. If I wanted to say something like f of 5, all right, so 4 times 5 minus 3, right? 4 times 5 minus 3, 20 minus 3, that's 17. Right? We could go on and on and on. Whatever number I plug in here, I plug in for x. Right? What if I plug something like f of x minus 1? Whoa, Stevens, wait a second. All I have to do is replace this x with whatever's inside here. Well, currently this says x minus 1, so I'd write 4 times x minus 1 minus 3. And now here all I'd have to do is distribute, right? 4 times x, so distribute here and here, so I get 4x minus 4 minus 3, and that simply is 4x minus 7. Right? But now, let's see what happens if I write something like f of g of x. Whoa, so I have to replace, I'm going to replace this x, right, because it's the f function, right, the f function. I'm going to replace this x with g of x. Well, g of x is negative 2x plus 1. So here I'm going to write 4, right, 4x minus 3, 4x minus 3. But inside here I'm going to give it a negative 2x plus 1. And now here I'm going to distribute, right, red rover, let the 4 come over. So I get negative 8x plus 4 minus 3, which simplifies to just simply negative 8x plus 1. Okay? Now I'm going to show you when this might get a little tricky. Some of the trickier ones that you might come across. What happens if I have, let's try f of x equals 2x squared plus 3x minus 7. And let's let g of x equal, I don't know, x plus 3. Okay? All right. Now, if I wanted to do g composed with f at x, right? Let's say that these are the directions. Find g composed of f at x. Well, that means that g, right? Well, hang on. First, let me rewrite it. We have g, f, and x. Then I put my parentheses. So this tells me f is going inside of g. So f here is going to go inside of g and replace this x. All right, so then I have this x plus 3, right? X plus 3 is the g function, and f of x, all this is going to go inside. So then I get 2x squared plus 3x minus 7. And now I can combine my like terms, so I'd end up with 2x squared plus 3x minus, well, negative 7 and 3 is my negative 4, right? Now, let's see the trickier version of this, or the trickier thing here is what happens when I have to plug g inside of f. All right, so I look at f composed with g at x. Again, I want you to rewrite this. Letters stay in the same order. F, g, and x. So this now tells me that the g function is going inside of f. So g, x plus 3, is going to go inside for all of these. So I'd end up with 2, this is x plus 3 squared, right? 2x squared plus 3x plus 3, and here I got to put the g function in, minus 7, like so. Now I need to be really smart. This is x minus 3 squared. So really this says 2 times x plus 3, excuse me, x plus 3 plus 3 times x plus 3 minus 7. Now I got to multiply 2 times x plus 3 times x plus 3. I'm going to save the 2 for last on this. X plus 3 times x plus 3. We got a FOIL. X times x is x squared. X times 3 is a positive 3x. 3 times x is a positive 3x. 3 times 3 is 9. Then I'm going to distribute. So 3x plus 9 and minus 7. Now I'm going to combine my like terms. So I get 2 times.
7 students, this is just a reminder that today's schedule is an even schedule. You will go to 2 for advocacy, 6 and 8. Today is an even schedule. Thank you.
Now I'm going to distribute the 2 plus 12x plus 18. And now I need to combine my like terms. So I have a 12x and a 3x. So my final answer is going to be 2x squared plus 15x. And then the 18 and 2 gives me 20. This is going to be one of the more difficult examples, but I trust that you're going to be able to handle this one no problem.